Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the autocorrelation function of the output response. The example is, assume a random process x of t is given as input to a system with a transfer function h of omega is equal to 1 for minus omega naught to plus omega naught. If the autocorrelation function of the input process is n naught by 2 del of tau, find the autocorrelation function of the output process. So coming to the solution, given that the transfer function of the system is h of omega is equal to 1 for minus omega naught to plus omega naught, and given that the autocorrelation function of the input process x of t is rxx of tau is n naught by 2 into del of tau. So in this equation, given autocorrelation function, given input autocorrelation function, take the Fourier transform on both sides. So Fourier transform of Rxx of tau is equal Fourier transform of RHS theorem. So we know that the Fourier transform of the autocorrelation function is four spectral density of x of t, that is Sxx of omega is equal Fourier transform of Rxx of tau. And now here Rxx of tau is n naught by 2 into del of tau. Substitute that value into here. So n naught by 2 is constant, that is written before Fourier transform. So n naught by 2 into Fourier transform of del of tau. So we know that the Fourier transform of the impulse function is 1. So n naught by 2 into 1 is n naught by 2. The four spectral density of the input process is n naught by 2. So now here we want to calculate the autocorrelation function of the output process y of t. So we know that the four spectral density of the output y of t is Syy of omega is equal magnitude of h of omega whole square into Sxx of omega. From the given data, the frequency response of the system h of omega is 1 and Sxx of omega is already calculated here, and substitute those two values into this equation. We get Syy of omega is equal 1 square. H of omega value is given that 1. So 1 square is 1 into n naught by 2, which is equal to n naught by 2. So now here we want to calculate the autocorrelation function of the output y of t. But we know that the Fourier transform of autocorrelation function of output y of t is four spectral density of the output y of t. So that is and using Ryy of tau and Syy of tau are the Fourier transform pair, that is Ryy of tau is equal F inverse of Syy of omega. So now here Syy of omega is already calculated, that is n naught by 2, and substitute that value into here. So using the definition of the inverse Fourier transform, F inverse of Syy of omega is 1 by 2 pi integral, given that the range of the frequency is minus omega naught to omega naught. So now here Syy of omega is n naught by 2 into e power j omega tau d omega, and the given data the range of the frequency is minus omega naught to plus omega naught. So now we are integrating with respect to omega. N naught by 2 is constant, that is written before integration. Integral e power j omega tau d omega is e power j omega tau by j tau over minus omega naught to plus omega naught. Now substitute upper value of omega and lower value of omega. We get Ryy of tau is equal n naught by 2 into 1 by 2 pi e power j omega naught tau minus e power minus j omega naught tau by j tau. So using Euler identity, e power jx minus e power minus jx is 2j sin x using that expression. So this numerator term is e power j omega naught tau minus e power minus j omega naught tau is 2j sin of omega naught tau. So numerator and denominator 2j is the cancel, and the remaining term is r y of tau is equal n naught by 2 into sine of omega naught tau by 2 pi tau. So this is the autocorrelation function of the output response y of t.